All right, let's take a look under the hood of 5G to see what really makes it tick. I mean, we hear about speed and low latency all the time, right? But the real magic, the secret sauce, is hidden deep inside its protocol stack.
So you might think 5G is this complete, total rewrite of 4G. But take a quick look. It's surprisingly similar. On the left, you've got your standard 4G LTE stack. And on the right, 5G. Those fundamental layers, the physical, MAC, RLC, PDC, and RRC, they're all still there. It's kind of like looking at two engines that honestly share the same basic design.
So that just begs the question, doesn't it? If the foundation looks so familiar, where in the world do 5G's famous speed and responsiveness actually come from? I mean, they clearly didn't reinvent the wheel. The answer, and this is the cool part, lies in some very clever, targeted upgrades.
So here's how we're going to break it all down. We'll start with that familiar foundation we just talked about. Then we'll dive into the crucial upgrades that give us that quality and speed. After that, we'll get into the two different worlds of 5G deployment, see how the data engine itself has been fine-tuned, and finally, we'll tie it all together and see why these hidden layers really matter.
All right, let's dive into our first section. The big idea here is that 5G builds intelligently on the success of LTE. This was never about starting from scratch. It's all about refining something that already worked incredibly well.
And this is really the key takeaway for this part. 5G did not start from scratch. These 5 layers, they're the bedrock of the connection, you know? They handle everything from the raw radio signals flying through the air all the way up to managing your connection. And by building on this proven foundation, well, 5G got a massive head start in both development and deployment.
Okay, moving on. Let's look at how two key upgrades really tackle quality of service and latency. And this, right here, is where we start to see the real genius of 5G's design. We're talking small changes with absolutely massive impact.
First up is this brand new layer called SDAP. That's the Service Data Application Protocol. The best way to think of it? It's like a really smart traffic cop for your data. Its main job is to look at all the different things you're doing. You know, maybe a high-priority video call over here and a low-priority background download over there, and it maps them to the right data pathways. But here's the catch. This layer only wakes up when you're connected to a true 5G core network. And one of its cleverest features is something called reflective QoS. Okay, think of it like this. Instead of your phone constantly having to ask the network, hey, how should I prioritize this data I'm sending back? The network just gives it a subtle hint on the data it sends down to you. It's like the network is just whispering, hey, by the way, this is important. And your phone just gets it. It reflects that priority back on the data it sends up. This simple trick saves a ton of back and forth chatter, time, and resources.
Okay, now for that speed upgrade. This one addresses that little bit of lag you sometimes feel when your phone has been idle for a bit. See, in LTE, waking up from idle mode actually takes a fair amount of time and a whole lot of signaling. So 5G introduces this brand new intermediate state to fix that.
And this just illustrates the difference perfectly. With LTE, your phone is either fully on, connected, or fully off, and idle. There's no in between. But with 5G, it can go into this inactive state, which is honestly the perfect way to describe it, a power nap. The connection isn't totally torn down, it's just suspended. And that is exactly why your 5G phone feels so instantly responsive. When new data comes in, it just sends a super quick resume message, and boom, it jumps right back to life.
But, and this is a big but, here's the catch. Not all 5G is created equal. Whether you get these awesome features actually depends on how 5G is deployed, and that brings us to the two different flavors of 5G, non-standalone and standalone. So think of non-standalone, or NSA, as a super high-performance 5G engine that's been bolted onto a trusty, reliable 4G chassis. It still uses the existing 4G network for all the control stuff. Standalone, or SA on the other hand, that's a brand new car from the ground up. It's got the new 5G engine and the new 5G chassis, the 5G core, for everything. And that's where features like SDApp and that instant-on power nap state really come to life.
This table really lays out the core differences. With NSA, you can see that everything kind of starts with LTE. Your initial connection, all the control signals, that's all happening on the 4G network. But with SA, you connect directly to 5G new radio. All the signaling happens over 5G, and you guessed it, that new SDAT protocol becomes active. So really, NSA is about leveraging the infrastructure we already have, while SA is what unlocks the full potential of 5G.
And believe it or not, it gets even more detailed. Even just within non-standalone mode, there are different ways to route your data. Let's think of it like a highway. Option 3, well, that's like forcing all the traffic through a single crowded lane.
It can create a real bottleneck. Option 3A is like opening up a brand new, super fast lane, but only for some of the traffic. But the one most carriers use, option 3X, that's like having a super smart traffic system that can dynamically split your data and route it across all the available lanes, both 4G and 5G, to get you there as fast as possible.
So how does 5G pull off all this cool stuff like intelligently routing traffic? Well, the answer lies in some pretty clever tweaks to those lower-level layers we saw earlier. Let's dive into the MAC and PDCP layers specifically to see how they've basically been supercharged for the 5G era. So, the MAC layer, it still handles all the basics like it did in 4G, but in 5G it gets two huge new jobs. First, it has to juggle multiple numerologies, which is just a fancy way of saying it can handle different kinds of signals all at once. It's like a symphony conductor making sure every instrument is playing in perfect harmony. And second, it's now in charge of beam management. This is the real secret sauce behind 5G speed. It's constantly tracking you and steering the signal directly to your device, almost like a laser beam of pure connectivity. And it's a similar story for the PDCP layer. It evolves too. Back in LTE, its main job was basically compressing and securing your data. But in 5G, especially in that smart highway option 3X we talked about, it becomes the main anchor point for splitting and routing data across both the 4G and 5G paths. It can even duplicate really important data and send it over both paths at the same time, just to make absolutely sure the connection is ultra reliable.
Okay, so let's pull back for a second. We've looked at all these individual pieces, the new layers, the different states, the deployment options. What's the big picture here? Why should we even care about all this hidden architecture?
Well, it comes down to this number. Over 90% of the protocol stack's foundation was just carried over directly from LTE. And that is the key insight. 5G wasn't some reckless rip it all up and start again rewrite. No, it was a masterclass in strategic, targeted innovation. It's all about building on a decade of technology that was already proven and stable.
So, what's the bottom line here? Look, 5G's magic is not about reinventing the wheel. It's about smart evolution. It takes the solid, proven foundation of 4G, then it adds a few absolute game-changing upgrades, like the STDPA layer and that power nap mode, to deliver that instant-on feeling. And on top of all that, it gives operators the flexibility to roll it out at their own pace. And that's why 5G is so much more than just a speed boost. It's a true platform for the future.
All these invisible layers, they're all working together in this incredibly complex dance of data and signals. And they create this amazingly powerful and flexible platform. And that, really, just leaves us with one final thought. Now that this incredible foundation is laid, what are we going to build with it next?